Hello everyone. So, in UV protective textiles we are now discussing different research studies. In last class we have discussed the effect of yarn twist and the yarn structure on UV protective performance of woven clothing, woven fabrics. Today we will discuss the effect of fabric thickness on UV protective textiles. Now, it has been reported that both fabric thickness and fabric cover they affect the UPF of fabric. Here what we have tried to eliminate the effect of cover factor by keeping the cover same, only we have tried to reduce the thickness, change the thickness, and thickness change was obtained by changing the diameter of yarn, okay, and percent cover we have kept constant, and in the present study what we have done, we have kept the warp density and warp count constant. So, keeping the same warp cover, what we have changed, the it is a weft cover was changed. So, D by P multiplied by 100, that it is a percent weft cover, where D is the diameter of yarn and P is the distance between two yarn, that is called yarn spacing. So, D by P is the total cover. If we see this portion, it is a P and here it is a D. Okay. So, P is the actual distance and covered distance is D by 2 and D by 2, covered distance is D. So, percent cover will be D by P. Two types of yarns were produced. If we see that finer yarn and it is a coarser yarn. So, to keep the cover same, for coarser yarn we have to increase the distance, that is if it is 2D is the diameter is doubled, then the spacing between yarn has to be doubled, so that percent cover remains same. But on the other hand, what we will observe, the thickness of fabric. So, if we with the simple calculation with the D yarn diameter, fabric thickness will be typically 2D. If we see the simple theory, it will be warp and weft diameter. So, effectively fabric distance will be 2D here, here the fabric thickness will be 4D. So, that is how keeping the same cover factor or percent cover, the thickness of fabric can be changed. And if we measure the fractional cover, which is given by d 1 by p 1 d 2 by p 2 minus d 1 d 2 by p 1 p 2, where d 1 by p 1 they are constant. If we keep this constant and d 2 p 2 we have to change in a fashion that d 2 p 2 will also be constant, keeping the d 2 p 2 constant. Okay. The fixed parameters warp count and ends density. So, warp count in English count it is 20 and ends per inch was kept constant 50. So, this was the fixed parameter. We have developed two different yarns, one is polyester and another is cotton. Now, to keep the cover percent constant, we have to adjust the peak density. in such a fashion that D by P ratio remains constant. Now, polyester yarn of 3 different linear densities were taken 20, 30, 40 English count and their diameters were measured. So, 0.235, 0.201 and 0.166 respectively for 20s, 30s and 40s count. Now, for 20s count diameter is 0.235, with that the diameter ratio will be definitely 1, because we are measuring with the reference of 20s count. For 30s count the diameter ratio it is 1.17, that is the 20s count diameter is 1.17 times to that of 30s count, and 20s count is diameter is 1.41 times of 40s count. So, these are the diameter ratio, and to keep this ratio constant and to keep the cover percent constant, we have to keep the peak density ratio same. For 20s count, if we keep the peak density as 40, then for 30s count which is finer, the peak density has to increase by 1.17 time, that is 40 multiplied by 1.17, it is coming out 47. Similarly, for 40s count which is finer in diameter, for to keep the same cover ratio, so we have to multiply this 40 by 1.41, that is why we are getting 56. This is a set 1, means one set of cover factor, average cover factor. This is the open structure with lower cover factor, keeping the same cover factor here for different weft count. Set 2 fabrics are with higher level of cover factor, but in set 2 the serial number 1, 2, 3 fabrics are having same cover ratio, and the peak densities were calculated based on the similar to the earlier, that is 59 is a result of 50 multiplied by 1.17 and 50 multiplied by 1.41, it is 70. So, similarly, the higher level of cover was developed with the peak density 60, 70 and 80, but for this set 3, although the overall cover is higher than the set 2, but the cover percent within set 3 for these 3 fabrics are exactly same. So, this was it is a cover ratio. Similarly, for cotton yarn the peak densities were changed to 40, 48, 54 depending on the diameter ratio, and set 2 with higher range of cover, and the highest range is with the set 3, but within that within each set the cover ratios are same. Then what is the basic difference between these 3 within set 1, set 2, set 3? In set 1, set 2, set 3, here the in set within set 1 the serial 1, serial 2, serial 3, the difference here is that not by the cover is same, but the weft count. So, the weft yarn count is becoming finer. So, effective thickness of the fabrics within set 1 will be different. So, serial 1 will have the highest thickness in a set, and serial 2, serial 3 will have least thickness. So, we can see the effect of thickness for same cover. Now, here set 1 with a least cover, set 2 moderate cover and set 3 is higher cover. So, this is actually we can see overall cover is increasing from set 1, set 2, set 3, but within the same set the cover is almost constant, that is what we have created. There is no specific trend. So, cover factor is constant for these 3 sets within the fabrics, and what was tried, the thickness is reduced with 20s count, 30s count and 40s count. So, for polyester here thickness is low, same cover factor for set, same set. Here also thickness is reducing. So, the fabrics within a set is having same cover, but different thickness. Areal density is observed to be little bit reduced here, but with the increase in cover factor the areal density is increasing, but for with the reduction in thickness also areal density reduces to some extent. Now, coming to the UV protective performance UPF, here in polyester fabric, if we see the cover percent at lower cover percent, the UPF changes is not that significant. For same cover percent, the effect of thickness at lower level of cover it is not that significant, but at higher level of cover when the fabrics are more compact, in that case the effect of thickness is visible here little bit, but with the increase in cover factor. So, 78%, 84% and 89% overall UPF increases gradually. So, overall cover factor if we increase, the fabric UPF increases, but for keeping same cover the reduction in thickness also reduces the UPF value, and this is evident at higher cover level, and this is without UV finish treatment on polyester. After UV finish treatment, so when we treat the fabric with UV finish, the total behavior changes. UPF it has been observed for all the fabrics first decreases, then increase with the decreasing fabric thickness. So, first decreases then increases. So, as the fabric thickness decreases, the UPF first decrease then increase. The trend in UPF with change in fabric thickness is different for untreated and UV finish treated polyester fabric, that we have observed. The untreated case, that is the former case, UPF reduces continuously. For the latter it first reduces and then increases with the decreasing fabric thickness. So, this reason we had investigated further. This is not any simple trend. So, there must be some other reasons. UPF of polyester fabric before and after treatment, when we study, the area of individual pore reduces and the number of pores increases when the finer wefts were used with higher peak density use. So, here what we have done effectively we have done, we use coarser yarn with open structure and finer yarn with closer structure. And to keep the effective cover, that we have changed the peak density. So, this effectively means one larger pore has been divided into many smaller pores. Because cover effective cover percents are same, just to change the yarn count, yarn linear density from thicker to thinner, what we have done? We have divided the larger pore to a many smaller pores, that is what we have done. This is, that means it is not only the thickness change here and keeping the pores constant. What we have done? We have broken the big pores into large number of small pores, keeping the overall pore area same, and this may lead to increase in UPF as smaller pores have more probability to be covered either due to yarn flattening or due to the presence of hairs. So, here if we see the hairs present, but during the process the smaller pores will have higher probability to be covered further due to flattening of yarn and presence of this hairs, but larger pores will remain open. So, this may lead to increase in UPF as smaller pores have more probability to be covered either due to yarn flattening or due to presence of yarn hairiness, and this effect becomes more prominent at higher cover percent, and it also magnifies if the UV absorbing materials are used, that we have seen here. This is a larger pore and this pores with higher peak density, this is pore, this one pore is actually divided into many pores. Total area, fabric set with 89% cover factor, this is 20 Ne with 60 ppi, 30 Ne with 70 ppi, 40 Ne with 84 ppi. So, here pore size, less number of pores, but pore size are higher, here more number of pores with a smaller pore size. So, here we can see the chances of flattening and covering of pores are more due to flattening and the hairs are covering the pores. So, in this case we will get more UPF value than the earlier. You can see here 20, 30, 40 and covering is probability of covering here is more. Similarly, to fabric set cover with 84%, these are the mean pore area 64, 52 and 45 square millimeter multiplied 10 to the power minus 3, this much, that means, so 0.045 square millimeter. Similarly, for set 2 84% cover, it was from 45 to 64, here 26 to 37. Now, it is further reduced at the higher cover, it is 17 to 18, at that zone it is there. So, as the fabric thickness reduces, we have observed that UPF also reduces, fabric cover was kept constant. As size of pore reduces, the UPF increases. So, that is why the pore size is also important along with the thickness. So, if we try to reduce thickness keeping the cover constant, we are at the same time reducing the fabric pore size. So, these two effects here, reduction in thickness and reduction in pores, they are working in opposite fashion. So, as the we are trying to reduce the thickness, we are reducing the pore size. So, they are affecting in opposite direction, that is why initially there will be one impact which will reduce the UPF, then after that the pore size will come into picture and the application of UV finish will enhance this effect. Now, as far as cotton fabrics are concerned, for set 1, as we increase the PPI, so there is no effect on the cover because we have tried to keep the cover percent constant, but with the increase in pix per unit length PPI, the overall cover has increased. This is set 1, set 2, set 3, that is why cover overall cover is increasing, and thickness was observed, it is reducing, that is what we have tried to reduce the thickness of fabric by changing the yarn count, and aerial density is also reduced here along with the thickness. Now, UPF without treatment, it is showing there is no specific trend is observed here, because here of the facts we have discussed, that is the reduction in thickness UPF reduces, and with the reduction in cover percent UPF increases. So, reduction in pore size UPF increases. So, these two factors is coming into play together, that is why their impact on UPF is not that visible here for untreated cotton fabric, but for treated cotton fabric, at least for higher cover, the trend is that consistent increase in UPF. This is very prominent here, UPF from 84 to 130 it is increasing. So, the effect of thickness and individual pore size are opposing each other, as I have mentioned while determining the UPF. At low level of cover percent, the effect of thickness is dominating over the pores, because pores are already in larger size. However, if the pore size reduces beyond a critical value, it is more dominating effect than thickness in determining the UPF. So, the critical value when it is we are talking about 96% cover, in that case the change in pore size here, the change in pore size keeping the cover same, we are changing the pore size, the breaking the larger pore to smaller pore when we are using 20s count to 30s count. So, this effect is prominent here, that pore size effect is dominating here. So, set 1 the mean pore size reduces. So, the overall conclusions are the no visible effect of yarn twist on cotton woven fabric on UPF was observed within the experimental range. For 100% polyester, UPF of fabric decreases with decreasing fabric thickness when fabric cover percent is kept at the same level. However, after UV finish treatment, UPF first decreases, then increases with the decreasing yarn thickness at same cover. Cotton fabrics exhibit no change in UPF with decreasing thickness at constant cover, but after UV finish treatment cotton fabrics UPF shows similar trend like polyester at higher cover factor, that is 88% cover. However, UPF increases continuously with decreasing thickness at higher level of cover. At low level of cover and with unfinished material, thickness has predominant effect on over the pore size, because at low level of cover that effect of thickness is predominant, but at higher level of cover the effect of pore size is predominant. Here we will end our topic on UV protective textile. In next class we will start one new area of technical textiles. Till then, thank you.